Hi, everyone. Joining me today from Boston is Christian Weeks, CEO of enVerid Systems. Christian, welcome to Healthy Air.
Great to see you, Eric. It's fun to be here.
Great to have you. So I want to share Christian's background briefly to provide context for our conversation. Christian Weeks is the CEO of enVerid Systems, a leader in indoor air quality and energy efficiency. Christian has over a decade of experience in energy efficiency and indoor air quality and is passionate about helping buildings achieve their energy efficiency and indoor air quality goals through smart investments in HVAC systems and proven air cleaning technologies. Prior to enVerid, Christian was an executive with EnerNOC, a leader in demand response and commercial and industrial energy efficiency solutions, which was acquired by Enel X, and a management consultant with Deloitte Consulting. Christian lives in Boston and is a graduate of Dartmouth College and the Harvard Business School. All right, so great and really impressive background, Christian. To start off, tell us about your path to enVerid and a bit of background on your current role.
Sure, good place to start. So I've been the CEO of enVerid for a little over 2.5 years now. The company's been around for 11 years, so I came in sort of midstream and joined the founding team to help build this business and grow it. But how did I get here? So I did a liberal arts undergraduate degree, as you noted, at Dartmouth. Studied political science, but decided rather than go be an intern on the Hill or something like that, I wanted to get in the business world. I've always wanted to have an impact, and I thought maybe I could do that through business. And started out not really knowing where in business I wanted to focus by joining Deloitte Consulting as a business analyst and essentially completing an apprenticeship in business. That's how I like to think of my 3 years at Deloitte, working with partners as an analyst in financial services and supply chain and consumer products. Just learned a ton, had a lot of fun, and decided that I wanted to continue to be, in business to try to have an impact through business, but also decided I didn't want to do that as a consultant, as a road warrior traveling all the time. I wanted to own the solution, implement the solution, see it all the way through, and maybe have a little more of a family life as I grew older. So I decided to make that transition by going back to school, getting an MBA, getting some formal business training, and then pivot from an MBA into the clean tech space, as it was called at this time. Now it's sometimes referred to as climate tech. I think both are good applications or good names for the space that we're in. And I pursued that because I felt it was an area where I could do well and do good. I could be in business, build teams, try to build companies, bring interesting technologies to market, but also try to deal with this climate crisis, which is only getting worse. So I did my MBA. I spent a lot of time during my MBA at Harvard, down the road at MIT, learning about all these new technologies. They had a much more robust energy club and a lot of smart scientists figuring out how to bring down the cost of solar PV and develop new battery storage technologies. And so trying to figure out what was going to be interesting for me, where I could contribute, where I could find a good home as I sort of made that transition, and ended up connecting with some Dartmouth folks and learning more about EnerNOC. And so I spent a summer at EnerNOC. I then went there after business school and spent almost 10 years at EnerNOC, really growing up in sales and marketing, a little bit of strategy, and eventually in various general management roles. I had the chance to run EnerNOC's business in Australia and New Zealand for a few years, which was a ton of fun, moving down under with my family, and then came back and ran a global business and then a North America energy efficiency business after we sold the company to Enel X. So really a fun run there, growing into general management roles or business leadership roles. But eventually said 10 years in EnerNOC, that's a great run. Now new ownership, a little different culture, which didn't suit me quite as much. And so I decided to have a look around, see what else was going on in the Boston clean tech ecosystem. And that's how I learned about enVerid. So we'll talk more about enVerid, but that's my brief journey from liberal arts undergraduate to working in climate tech and trying to solve problems related to air quality and energy efficiency in buildings.
Great. Okay, so let's pick up on some of that. So just to kind of set the scene for our discussion, how significant at a macro level is the carbon footprint of the built environment relative to other major sources of carbon emissions? And then within the built environment, how important and how significant is the HVAC system and in this carbon footprint?
Yeah, so it's a great place to start. Building operations and building materials together contribute nearly 40% of global carbon emissions. And to put that in perspective, the GHG emissions from buildings exceeds the emissions footprint of the transportation sector and the industrial sector. So buildings, and this would include residential, commercial, and industrial buildings, are a huge factor when we look at the overall pie of what's contributing to global warming and carbon emissions. And we see this especially, and probably not surprisingly, in cities like Boston, where I am, and in New York City, where you have a high density of buildings, many of them very tall buildings. In these cities, over 70% of carbon emissions come from buildings. So we have to address buildings to address climate change, and that's why solutions like ours are so important. If we go within the building, it turns out that in commercial buildings, on a typical commercial building, over a third, 36% of a building's energy intensity is related to HVAC, or heating, ventilation, and air conditioning. And as I said before, in climate zones where you have hot, humid summers and cold winters, a lot of that 36% of energy intensity from HVAC is associated with heating and cooling all this outside air and moving it through a building and exhausting the old air. And so buildings are a major contributor. We need to solve this issue as we're going to address climate change. And heating and cooling is probably the biggest and maybe the most challenging component within the building. Lighting is a little more straightforward. A lot of people have done lighting retrofits. Solar panels are, of course, great, and the cost has come down so much that now that's become much more common. The mechanical systems, the central plant, that's the tougher challenge, and that's where we've decided to focus.
All right, great. So now let's dive into those. So as you said, the built environment is a huge contributor to carbon emissions. And within that, the HVAC system is about a third of that, or responsible for that carbon. Where are the opportunities to reduce the carbon footprint, and assuming that the HVAC system is going to be a big piece of that, what can we do? And then where do enVerid solutions come into that? And I think giving us a kind of overview of what your technology is, which is super innovative stuff, would be very helpful too.
Yeah, sure. So, the nice thing here is that we've got a great solution, but this is a chance to talk about all the important solutions that we need to be deploying in these buildings, because it really is going to take an all of the above strategy, and many of these different approaches or technologies are complementary to each other. So, heat pumps, for example, are getting a lot of attention as a more efficient way to heat and cool buildings. Building envelopes, tightening up buildings so you don't have leakage and you can control temperature better. Recently, I've been reading more about glass technology that can tint itself and adapt to where the sun is, and result in less heating and cooling loads in buildings because they can maintain temperature by preventing all this warmth coming through sort of glass windows. There's a company called AeroSeal that is sealing ducts to make ducts more efficient and less leakage and inefficiency from that. So there are a lot of different technologies that are coming, that are being developed to help us solve this carbon issue in buildings. What's, again, really cool is that what we've developed at enVerid is incremental, it's additive, it complements these other technologies. But as I said, it really addresses sort of a core challenge, which is how do we address this old paradigm of bringing in lots of outside air to achieve good indoor air quality? How can we make buildings energy efficient and have healthy, safe indoor air quality at the same time? So maybe I'll use that as a takeoff point to talk a little about enVerid and what we've developed. As I said, enVerid was founded about 11 years ago now around a kitchen table in Newton, Massachusetts, by a PhD from MIT, a PhD from Tufts. And these were two really smart scientists who had become entrepreneurs and had done things in various industries, but decided they wanted to do something in buildings. And so they were looking at the buildings as outsiders and looking at things like how much oxygen we have in buildings and how that impacts health and wellness. And in looking at these different things about buildings, they discovered this whole phenomenon around dilution ventilation to solve this pollution issue. And as outsiders, they said, this is insane. It's like we're trying to maintain good air quality in buildings by just opening the windows, essentially, by bringing in all this outside air. And if you think about that, you think about your home. Imagine in the summertime in Boston, it's 100 degrees, it's humid, and we're going to make sure we keep fresh air inside by just opening the windows, right? If that was the way we were going to run our homes, we'd have to put in bigger HVAC systems. We need to run them harder. We consume a lot more energy. We'd emit a lot more carbon. To our founders, that was essentially what we're doing in buildings. And so they said, there's got to be a better way. Why can't we clean the air in buildings? And what they did was looked at what NASA and the Navy do in spaceships and submarines, where you can't bring in outside air. And they figured out that NASA and the Navy had solved this problem. They figured out how to basically scrub the indoor air, remove these gaseous or molecular contaminants like VOCs and formaldehyde and CO2 as from people. And they set out to figure out how to make that technology work in commercial buildings in a viable way, commercially and technically. And so after many years of R&D and collaboration with places like MIT and the DOE and University of Southern California as well, we figured out how to do that. We figured out how to take this concept from spaceships and submarines and have it apply in buildings in a way that worked technically and was cost effective. And that's what we've been doing. So essentially what we have developed is what we call sorbent ventilation technology. And it's a sorbent-based media technology that is deployed in buildings as part of a piece of equipment we call a HLR module, stands for HVAC load reduction module. And these modules have sorbent filters in them. And these sorbent filters, as air passes through them, capture these molecular contaminants. So we're removing them from the airstream. We're capturing CO2 molecules from the air. We're capturing formaldehyde and other VOCs from the airstream and allowing clean air to return to the building and be recirculated. A key technology breakthrough that enables this is the fact that as we saturate with CO2, which comes from people and is the most prolific of these molecular contaminants in buildings, we've also developed a regeneration process where we can actually heat up our units, exhaust the contaminants like CO2 outside the building, and thereby recharge these cartridges and use them for 2 years without having to replace them. So that's critical in terms of the economics of this solution and a key technology breakthrough. But essentially, it's a sorbent air clean technology that is installed with mechanical systems, mixed air systems, dedicated outside air systems, can be deployed with energy recovery ventilation systems. But in every case, it's all about cleaning enough indoor air so that we don't need as much outside air to maintain healthy indoor air quality. And it's that cleaning and then adding, but not relying 100% on outside air, that gives us a more efficient way to achieve good indoor air quality.
You're basically offering a best of both, that you can not have the trade-offs that many people in this space, highlight oftentimes, of you can either optimize around health and safety, but then you're going to have some real energy and carbon cost penalties associated with that, or vice versa. For skeptical audience members, can you talk a little bit? I mean, you've talked about just kind of the recirculation and cleaning aspect, but how can you have it both ways? Just pushing you a little bit on that. Like, what is the pathway to having it both ways, where you're optimizing around both of those things? And then also, candidly, where do you think there are still real trade-offs for people?
Yeah. Well, it's interesting because with COVID, well, let me maybe step even back from COVID, go back to the 70s with the oil embargo and everybody trying to economize and be as efficient as possible. Back then, that whole movement led to everybody tightening up the building envelopes and minimizing ventilation. But what came out of that? Sick building syndrome. And so we've had to walk back some of those measures to tighten up the buildings and reduce the ventilation rates. And ASHRAE and others have updated the standards around what are appropriate ventilation rates to ensure acceptable indoor air quality. But if we take the other extreme now with COVID, right, we've seen this heightened awareness and concern about the air quality in buildings. And the initial guidance was the exact opposite of what we saw in the 70s. It was, let's maximize outside air, let's bring in as much as possible. But when ASHRAE put out that guidance, they very quickly got pushed back because people were quickly realizing how expensive it was to bring in all this outside air. And so ASHRAE has done a lot of good work and research, and your group, St. Christians, has done some of this work as well, and helped build an awareness around a sort of a new framework for thinking about health and safety in buildings. And it's based on not just air change rates based on outside air ventilation, but we're now calling equivalent air changes per hour. And it's this notion that, which is reflected in the current ASHRAE core recommendations for COVID that were published in January. It's this notion that we can take a layered approach, a flexible layered approach that combines air cleaning and filtration with ventilation to achieve desired exposure reduction goals, but do it with an eye towards not only comfort, but also the technical feasibility of our mechanical systems, as well as the energy associated with different strategies. And so this whole concept of equivalent air change rates and layered strategies that combine cleaning and filtration solutions with outside air ventilation, that allows us to achieve healthy, safe indoor air quality more efficiently. And that's really what EnerNOC has been saying, frankly, from the beginning, that let's clean the air as much as we can. And we're not going to ever eliminate outdoor air ventilation, but maybe we don't need as much as we had before, because we can essentially accomplish the same end by cleaning and recirculating, this clean indoor air. So EnerNOC's been sort of preaching this from very early on, but somewhat ironically, because initially with COVID, nobody wanted to hear about reducing outside air. But the focus then on energy and sustainability has forced us to reevaluate and rethink the paradigm a little bit. And so now I think it's actually much more accepted that, yeah, we can use high MERV filters, we can use HEPA filters, we can use different air clean technologies to control these contaminants at their source, which is more efficient than relying on this outside air. So both are possible, but every building's a little bit different. And so, what we certainly aren't going to just, write a prescription for every building. The equipment is of a different age. It's been maintained differently. You've got some great technology to go and test, how these systems are actually working and what might need to be done to enhance them, or how they might be supplemented with air cleaning and filtration. But I think the big takeaway, is we can't go back to the 70s, and we can't go to what we initially did after COVID. We have to find a way to combine these different technologies, filtration, air cleaning, and ventilation, outside air ventilation, to get the desired, air quality targets we want, but do it as efficiently as possible. And this is what we're starting to call at EnerNOC sort of the pathway to sustainable and resilient indoor air quality, where really we marry the two and we have a way to achieve both. So how do we convince the skeptics? We have to add monitoring. I think that's the other piece that EnerNOC hasn't really gotten into yet. But we're starting to think more and more about a framework where it starts with defining your indoor air quality targets. What do we want to achieve? You can think of it in terms of risk with COVID, like number of effective air or equivalent air changes, or you can think of it in terms of CO2 or some other metrics you might want to have. Then it's about, let's deploy as much air cleaning and filtration as we can to control as much of that as we possibly can efficiently with those technologies. Then let's use performance-based ventilation design standards to figure out, okay, how much outside air do we need to add on top of the air cleaning and the filtration to achieve those targets? But the last piece then is the monitoring. It's bringing in your technology, bringing in, IAQ monitoring to say, okay, are we maintaining those levels, and do we need to adjust? Bring in more outside air, bring in less outside air. Maybe we want to be adaptive to, are there wildfires happening? Is it an ozone alert day in New York City today? But that last element of monitoring, I think, actually really completes the cycle and can give people the comfort that we're able to achieve, healthy, sustainable indoor air quality, and hold ourselves to that, make ourselves accountable to demonstrating that we're actually achieving that.
So the legacy of the 70s and the sick building syndrome that you referenced has led there to be, rightly or wrongly, a stigma around recirculation and a negative connotation. People hear, air recirculating, and it immediately conjures up kind of stale air, people getting sick. And essentially, I don't know if you feel this is a fair characterization, but you're providing a value proposition of good recirculation, or there's a way of making recirculation not a bad thing, but a good thing. How is the market, and I guess the market broadly defined as people that you're trying to sell your technology to, or even experts in the field, how are they reacting to this idea? And it would be great to hear your notes from the front lines of this.
Yeah. Well, I do think that it is a new paradigm, and therefore it's going to take some time for people to embrace it. And of course, there are naysayers and those who are slower to adopt than others. It's interesting because I've recently been thinking about this paradigm shift, and whether COVID is the event that kind of changes this paradigm. enVerid in 2019 received the Product of the Year award at the AHR show. And in announcing the award and describing enVerid, they described our technology as game changing. On the one hand, as a sort of entrepreneur, I thought that's awesome. We're onto something new. It's interesting. It's recognized. On the other hand, game changing for many people is scary. It's different. It's innovative. It's what if it doesn't work? It's all these things. And so, but at the same time, while it's scary, we can't just keep going on the way we're going, right? COVID showed us that, if we're going to start designing buildings to be able to support 100% outside air, right? We got to spend a lot more money on equipment. We're going to spend a lot more money on energy. We're going to emit a lot more carbon, and that's just not an option. We just can't do that. And so, and at the same time, technologies like ours have come along. They didn't exist. They weren't commercially available 10 or 15 years ago, or even 5 years ago. And so, there's certainly been, initially a lot of skepticism. You're saying, wait a second, we don't need to bring in all this outside air. We're going to clean the air instead. Then we get in the models, and we can sort of show people the risk analysis and the air change rates, and what a MERV 13 filter can do, and what we can do with our sorbent filters. And sometimes even then we get people to say, I've had somebody tell me once, you are technically correct. I believe you. But, I've got all these tenants that I need to get back to the office. I need to explain this to them. I've already told them I'm increasing outside air. Then you get the change management aspect of this, right? So change is going to take time. But I think it's become an imperative. We have to start heading in a slightly different direction here. And I think the piece that maybe gets us there in the end is the advances not only just in air clean technologies, but in monitoring and validating, right? The air cleaning. And this is, again, where you all have innovated as well. I was talking to somebody else in the industry recently, and they said, 20 years ago, I guess it was, nobody wanted security cameras on their loading dock, right? They were worried about what that might uncover, and they'd be liable, and, we can't have that. Knowing is a liability. I can say that 6 months ago, earlier in the pandemic, maybe a year ago now, people were telling me, putting more air quality monitoring in buildings is going to be a liability. I don't want to know because I'm responsible. Well, more recently, people are saying things like not knowing is the real liability, right? Just like with security cameras now, nobody would think to not have security cameras around your building, your loading dock. We're going to see that with air quality too. And I think that it's going to take time. It's going to take time, but ultimately it's inevitable. And the developments in new technologies, both in terms of cleaning, but also in terms of monitoring and testing, are going to make this possible and ultimately get people comfortable that this does work.
Yeah, I see some really interesting analogies. We're coming at this at Safe Traces more from a biotechnology standpoint, but as I look at things like in the food and agriculture industry, where a lot of biotechnology was stigmatized as well, whether it was GMOs or chems being used, or even lab or cultured meats or so forth, that is completely changed over the past 5 to 10 years. In many cases, people are much more embracing of that because of the climate aspect. And I see a similar case with recirculation, where there's a whole reframing of how people need to think about good versus bad recirculation. But ultimately, what that does is it gives you a viable chance of having health and safety and sustainability and not having to choose between those two things. But as you say, it's certainly an evolution and a change management dimension that's critically important. So moving on. You out in the real world are active in lots of different market segments. So offices, K through 12 schools, higher ed. It would be interesting to hear from you on how your tech is being received by customers in those markets, and what are they making their decisions on? Are they compelled by sustainability, by health and safety, by the financial aspects, all of the above, and how are those weighted differently within those markets?
Yeah. So maybe I'll focus on where we've done most of our work at enVerid, which has been Office, K-12, and also higher ed. Maybe starting with Office, it depends a little bit on the ownership structure. Corporate real estate, owner occupiers versus commercial real estate. But I think across the board, what has, initially, I would say energy efficiency was really sold on the payback, right? On the financials, what the CFO could sort of sign off on. And that is still, happens a lot. But I think what's starting to change, what we're seeing more of, is that organizations like RES and investor groups and others are saying, are putting much more scrutiny on these sustainability metrics, not only because of climate change, but what they've actually, I think, started to conclude is that companies that are scoring well on sustainability metrics are just better run companies overall. Yeah. And so the mandate for sort of commercial real estate is maybe now as much around the economics, the payback period, as it is around needing to improve your Energy Star score or your GRES score, because your risk then goes down. You can borrow at lower rates, right? It's working through the whole, capital market side of the market. And so I think that's, an interesting an evolution there. But it's certainly, I still hear a lot of people say it's got to be a 2 or 3 year payback, which you could do maybe with lighting and some other technologies, but with HVAC, it's often going to be a little bit more. So hopefully that continues to relax a little bit. But I will say also with COVID, though, where the pendulum may have been more skewed towards energy and, energy conservation measures and strong payback periods, certainly what we're hearing a lot from the office market now is it's really about, mostly right now about getting people back to work and confident in healthy, safe indoor air quality. And so they're even willing to incur an energy penalty, or spend some more money on the air quality, in the indoor air quality, healthy building aspect. Mm-hmm. So I would say it's around, for office buildings right now, I would say, it's really number one is the air quality, the health and safety, just get people back, make sure people renew their leases and come back to the office. And then it's probably the investor pressures around the sustainability metrics and then the financial ROIs are still a threshold, but maybe not number one like they were, pre-COVID and even some years ago. In higher ed, there's more willingness to do sustainability as part of sort of this is what we need to do as good citizens. This is what we need to do to attract the younger generation, which cares about energy and sustainability and what their plan's going to look like when their parents and grandparents, and they're not necessarily under the same sort of, they're not operating under the same parameters of a public company, let's say, or, a privately held company that's focused on their earnings and such. So, we see payback period, more flexibility, 6, 7, 8 years sometimes is acceptable for these, higher ed institutions that are focused on, doing their part around climate change for the right reasons and to attract, students and play their part. I would say with K-12, the challenge there, especially in the public school system, is just a little different now with COVID, all this money flowing in, but for a long time it's been just really tight budgets and a lot of concern around just their operating expenses, and we get pushback around, you're talking about another piece of equipment I have to maintain, so they're short staffed and they're just trying to keep their current systems running, and we're saying add another air cleaning system that needs filters replaced every 2 years. So I would say with the K-12 market, historically it's been much more, financially operating expense driven, and where we can show them how we can save them money. That's been very helpful. I think more recently though, there's a big push in many states now are requiring new schools to be LEED certified. And the next thing now is driving everybody to net zero, energy designs. So in more progressive states or parts of the country, I think we're seeing, that become more and more important as well. And with the advances in technology, it doesn't necessarily have to cost more. I think more and more people are realizing that they can do that. achieve that sustainability target without necessarily paying a green premium. So that would be my take there. It'll be interesting to see what happens with the school, market. Now there's all this funding, this COVID stimulus funding that's sort of, some of it's flowing, some of it's not yet flowing. It's being used in different ways, everywhere from buying people lunches, providing lunches, to making the right investments in infrastructure that we really should be making to ensure that these once in a generation funds that the federal government is allocating are used in ways that will benefit our school buildings, our indoor learning environments for the next 20 to 30 to 40 years. So we hope to see more of that, and hope that will stimulate an upgrade and investment in our school buildings, which is lacking. GAO, as you may have seen, I think it was last June, maybe put a report that said that 4 in 10 schools in this country have failing, basically, infrastructure, failing systems. So this is a chance with the stimulus funding to address that, and we hope that's what happens.
At the time that we're recording this in mid-September, you're coming on the heels of 2 major OEM partnerships with Trane and Daikin. I just wanted you to comment a little bit about those partnerships. What are you going to be doing? And then, where you see them going in advancing the kind of mission and business and strategy of enVerid.
Yeah, so we're bringing 2 technologies to market, and we have these 2 partnerships, one with each of these technologies. We have our core technology, what we're calling our sorbent ventilation technology. We've been selling HLR modules, with sorbent ventilation technology for many, many years now. But as you just pointed out earlier this week, in fact, we announced, or Daikin really announced, that they've upgraded their Revel applied heating and cooling system to include our sorbent ventilation technology as a standard option that can be selected using their selection tool. And they're going to make it available in the marketplace as a solution that enhances indoor air quality while also doing so energy efficiently. So this enables Daikin to offer, maybe a 50-ton rooftop system that can do what a 70-ton rooftop system might have been able to do before, because it has this air cleaning element. It also meets the lighter system. It's a smaller system. It's a system that's cleaning the indoor air. So we're really excited about that, because again, this gives the engineers the opportunity to incorporate this technology without having to worry about another system, more floor space, more ductwork. They can get it out of the box with a standard piece of equipment. And the vision with Daikin is to expand it to their other product lines, and to work with them to really promote this concept. And our hope is that it becomes industry standard. At the same time, we were excited a few weeks ago to announce that we teamed up with Trane to bring our HEPA air purifier to market. This is a system that is designed for classrooms, for conference rooms, for common areas where people gather. But using technology, which means it's much more focused on the particle contaminants, the aerosols that the virus, is carried, how the virus moves through the air. So this is a great solution for, local air cleaning, where we can't get enough done with the MERV filters on the central system. Maybe we want some additional air changes in a space where people are gathering. Maybe they're eating without their masks. It's a classroom with a lot of students. We want to keep them safe. And what we've done, which is innovative with that solution, is rather than doing a me too, there's a lot of HEPA solutions on the market. Many of them are sit on the floor, you plug them in the wall, they go in a corner. Unfortunately, many of them are pretty loud and oftentimes get turned down or even off, so sort of defeats the purpose. What we've tried to do with this is a ceiling mounted unit that you can hide in the ceiling plenum, or you can hang it below the ceiling if there isn't space. And we've got some ductwork that you connect to it to make sure you get good air mixing in the space. The ductwork also attenuates the sound, so it's much quieter. And it's out of the way. It can be centered in the room for good air mixing. And it's a great long-term solution, more so than a portable plug-in, which probably ends up in a closet as soon as possible because of the space and the noise it takes up and all this. So anyway, we're really excited that Trane has taken interest in this, and as part of their WellSphere initiative, which is focused on healthy, buildings and good indoor air quality, is offering this to the market through their network of sales folks across the country, across the U.S. and Canada, to help people respond to the challenges of COVID and in a way that we think is more durable and makes sense for the long term. So, yeah, we're excited about these partnerships. It's very exciting.
Yeah. Congrats, big milestones. Moving on. So looking out 5 to 10 years, where do you see IAQ moving, at least the market generally, and then where you're playing in the market, and what do you see as kind of challenges and opportunities for enVerid?
Yeah. So our view of the future is that COVID is going to precipitate this new paradigm, this new imperative around achieving sustainable and resilient indoor air quality. And by sustainable, we mean energy efficient, cost effective, durable indoor air quality. And resilient is a reference to needing to be able to adapt to and respond to situations where the outside air is not clean. So wildfires, ozone alert days, these sort of things. So for us, the future is really around sustainable and resilient indoor air quality. And that is based on what's come out of COVID and the epidemic task force in the latest guidance. It's based out of on a framework where we start with defining what air quality means, good air quality means for us. We can look at the LEED as a standard. LEED has some metrics we can refer to. WELL, has metrics we can refer to. There's a reset standard. ASHRAE is in the process now defining, indoor air quality metrics the way they haven't before. So we got lots of references we can use, but start with those. Then add these air cleaning technologies, MERV, HEPA, different technologies, sorbent ventilation technology as we offer to clean as much of the air as you can. Then finally, use that performance-based ventilation design standard to figure out, okay, on top of the air cleaning we have, what do we need in terms of ventilation? Not only balance the building, but make sure we achieve those indoor air quality targets. And then add that last piece, add that piece around monitoring and assurance. So that is what we see the future. It's the pathway, the framework for sustainable and resilient indoor air quality. It's based on this concept, again, from COVID of equivalent air changes per hour. It's this notion of let's clean first as much as we can, and then supplement, add, fill the gap with outdoor air ventilation, but move away from this concept of dilution ventilation is the solution to pollution. So that's what we see as the future. We're excited about it because I think it allows us to deliver healthy spaces and do it energy efficiently. It allows us to make sure people have good working environments, learning environments, living environments, while at the same time confronting this climate crisis and being more adaptive and resilient to the heat waves and the wildfires and these sort of things happening all around us.
Mm-hmm. Well, great discussion. Before we go here, I want to give you the floor to share any parting thoughts.
Well, it's an exciting time. Maybe the thought to leave everybody with is that out of these crises like COVID, they force innovation. They force us to think in new ways, in new paradigms. And so, as hard as COVID has been, maybe the parting thought here is something we've been thinking a lot about, which is what do we learn from this? How do we adapt to this? And how does this create new ways to think about the future in ways that create win-wins out of tug of wars and scenarios which have been sort of either or in the past. So let's not waste the crisis, I guess. I think somebody else probably said that more eloquently. I forget the quote exactly, but COVID's been challenging. It's forced many people to adapt and adjust. We've learned a lot from it. Let's make sure we take these lessons and make them part of our future so that we can ultimately come out stronger than we were before.
Awesome. Well, great parting thought. I hope that we heed it as a country and a world, but we'll see. Thank you so much for taking time out of your busy schedule to speak with us, and wishing you all the best. Look forward to seeing what's next from enVerid, and great job on everything.
Thanks, Eric. It's great to catch up. Look forward to continuing to work together. Thanks a lot.